Hi everyone. Today we're going to solve system of linear equations using matrix inverse method. Let us discuss first the matrix inverse method. Consider the system of equations which is 3 by 3. This is the form where x, y, and z are unknowns. The matrix form is here. The matrix A is a 3 by 3 matrix that corresponds to the coefficients of the variables or the unknowns. The matrix X is a 3 by 1 matrix that corresponds to the variables x, y, and z. Matrix B is a 3 by 1 matrix that corresponds to the constants on the right side of the equations. So we have here d sub 1, d sub 2, d sub 3. Now, the solution of the system of equations is the matrix X equals the inverse of matrix A multiplied by matrix B. Let us see example 1. Solve the system of linear equations using matrix inverse method. We have here linear equations in two unknowns, and we have two equations. We have 5x plus 2y equals 4. The other one is 7x plus 3y equals 5. For our solution, let us write the corresponding matrices. Let's begin with matrix A. This is a 2 by 2 matrix that corresponds to the coefficients of the x and y respectively. So we have 5, 2, 7, 3. Next matrix is B. This corresponds to the constants on the right side of the respective equations. So we have 4, 5. Another matrix is the X, and this is a 2 by 1 matrix that corresponds to the variables X and Y. Now we say that the solution of the system of linear equations is given by the matrix X equals the inverse of matrix A multiplied by matrix B. There are two methods of finding the inverse of 2 by 2 matrix. The first method is the n by 2n augmented matrix method. Second method is this formula: A inverse is equal to adjoint A over determinant of A. This method B is sometimes called the shortcut method. To review, we have the shortcut method that we use to compute the inverse of a 2 by 2 matrix. So given matrix A, which is a 2 by 2 matrix, the formula of the inverse equals 1 over determinant multiplied by the matrix that we call adjoint of A. Please remember, the formula of determinant is AD minus BC. Going back to our problem here, let us now use the second method formula, and we write also the formula of determinant. Then, let us write the corresponding matrix for our equation here. So we have the matrix X is here equals the formula of inverse. We copy the right side of this formula and we write here. And then the matrix B we copy here. Simplifying now this formula, first let us compute for the determinant. Using this formula, we have the 5 times 3 minus 2 times 7 When we simplify this, the value of determinant equals 1. Let us now substitute this value in here. So we will have now this 1 over 1. This adjoint will have the value 3, negative 2, negative 7, and 5. And then we just copy the matrix B. This 1 over 1 is simply 1. Now let us multiply this matrix by the matrix B. The answer will be 2, negative 3. Remember that we get this 2 if we multiply this row by the column. Also, the negative 3 will come when we multiply this row by this column. Now, writing the final answer, we say that the solution is x equals 2 and y equals negative 3. This is the final answer. Let's have example 2. Solve the system of linear equations using matrix inverse method. The equations are x minus y plus z equals 1. Second is 2y minus z equals 1. Third, 2x plus 3y equals 1. Let us now write the corresponding matrices. Matrix A is this matrix. This is a 3 by 3 matrix that corresponds to the coefficients of the variables. Next is the matrix B, and this is a 3 by 1 matrix that corresponds to the constants of the equations respectively. And then the matrix X is a 3 by 1 matrix, and these are the unknowns, x, y, and z. We say that the solution of these linear equations is the matrix X equals the inverse of matrix A multiplied by matrix B. There are two methods of finding the inverse of 3 by 3 matrix. The first method is the n by 2n augmented matrix method. The second method is this formula: A inverse is equal to the fraction with the numerator adjoint A over determinant of A. You can use any of these methods. The discussion of these methods will be done on the next video. Now, going back to our problem 2, when we solve the inverse of this matrix, we will get this resulting matrix. And then, let us substitute the corresponding matrix in our equation here. Matrix X is the x, y, z equals the inverse of A is this matrix, and we copy it here, then multiplied by matrix B, and we write it here. Simplifying the product, we have now the value of the matrix X to be 5, negative 3, negative 7. Remember that we get this 5 when we multiply this row by this column. We get negative 3 when we multiply this row by this column. And we get this negative 7 if we multiply this row by this column. So we write now the final answer to be, the solution is x equals 5, y equals negative 3, and z equals negative 7. This is our final answer. I hope you learned something from this video. See you again next time.